Welcome to another video from explainingthefuture.com. This time I'm at the 2014 TCT show in Birmingham, which is a massive 3D printing exhibition with all major industry players present. In addition to software, 3D printing materials and 3D scanners, TCT exhibits a wide range of both personal and industrial 3D printers. On the personal side, we have old favourites like the Ultimaker 2 and the Up Plus 2, recent favourites like the 5th generation MakerBot Replicator and the XYZ Printing Da Vinci, and brand new printers including the 3D from Puzzle Shed, the Robox from CEL, the Cube 3 from 3D Systems and the Up Box from Tier Time. The latter even includes a HEPA filter to stop fumes escaping from its enclosed build area. Industrial hardware at TCT includes direct metal printers such as the Pro X200 from 3D Systems and the M290 from EOS, as well as the SLM280 from SLM Solutions. There are also specialist industrial printers including the SolidScape Max 2, which produces highly detailed wax patterns for lost wax casting. 3D printers are based on a wide range of technologies, with many manufacturers referring to the same process by different names. To provide some clarity, in 2012 the ASTM standards body placed all 3D printing technologies under 7 generic headings, with 6 of these in live demonstration at TCT. Material extrusion 3D printers are most common and output a molten thermoplastic or other semi-liquid material from one or more printhead nozzles. Such printers include most personal hardware, as well as larger desktop devices like the Uprint SE from Stratasys and the Cube Pro from 3D Systems. There are also high-end, floor-standing material extrusion printers, such as the Fortus 400 ME. A recent and impressive innovation in material extrusion is the Mark I from Markforged. This can add a continuous carbon fibre or Kevlar reinforcement to objects extruded in nylon. As you can see, while nylon-only prints can be easily flexed, those with reinforcement are rock solid. The first 3D printing technology was vat photopolymerization, which solidifies objects on the surface of a tank of photocurable resin. This is demonstrated by stereolithographic printers like the Form 1 Plus, which selectively cure their resin with a laser. Alternatively, the DLP projection per factory printers from EnvisionTech solidify resin layers using a DLP projector. The EnvisionTech hardware can fabricate objects such as dental appliances or highly detailed jewellery patterns for use in traditional metal casting. Also at TCT, we find material jetting printers from both 3D Systems and Stratasys. These also build objects from photocurable resins, but here spray each layer from a printhead and set it solid with UV light. As I discussed in my last video, the Object 500 Connex 3 from Stratasys uses material jetting to build multi-material objects in colour. Next on our list are binder jetting printers that spray an adhesive onto successive layers of powder. These include the Project 4500 from 3D Systems, which sprays both a binder and coloured inks onto a plastic powder. This allows incredible full-colour plastic prototypes to be created, which is one of the signature 3D printing innovations of 2014. It would be so great to have a desktop 3D printer based on this technology. To build objects from a far wider range of plastic or metal materials, powder bed fusion uses a laser, electron beam or other heat source to selectively fuse powder granules together. This technique is already being used in industry to manufacture end-use parts, with a wide variety of 3D printed metal components on display at TCT. The detail and surface quality now being achieved in the direct 3D printing of metal is very impressive indeed, and surely indicates a direction of travel for the next industrial revolution. Powder bed fusion hardware that can directly print in metals is difficult to operate in a trade show environment. Even so, this feat has been managed by Realizer with their new selective laser melting SLM50. This is the world's first desktop hardware for 3D printing in metal and uses a laser to selectively melt together the particles of a metal powder where required. Once one layer is finished, the print bed lowers and a recoater arm sweeps fresh powder into place so that the process can begin again. I could watch the SLM-50 in operation for hours. The final 3D printing technology operational at TCT is sheet lamination in the form of the M-Core Iris. This forms object layers from standard copier paper with coloured ink sprayed on to allow amazing full-colour printouts to be created.
The TCT show highlights the increasing scope and scale of the 3D printing industry. Today I've seen some incredible 3D printers, but more so some incredible 3D prints, and particularly the things that have been fabricated in metal. More information on 3D printing can be found in my other 3D printing videos, on explainingthefuture.com, or in my 3D printing books. But now that's it from the TCT show, and I hope to talk to you again very soon.